Welcome everybody to this video about the basics of financial forecasting in public institutions. The topics covered are a basic overview about forecasting and public institutions. We are also going to cover forecasting models, and the last part is going to talk about scenarios, sensitivity and risk analysis associated with those forecasting models. Note that there is also additional information from the Government Finance Officers Association, and the link is embedded in this slideshow. So let us look at forecasting and public institutions. Think about financial forecasting as the process of estimating future financial outcomes based on historical data, economic trends, and assumptions about future policy. Those financial forecasts are important because they form the basis for informed decision making, because you are projecting revenues, expenditures, and service demand. You are going to have them to accurately build budgets, and note that we have seen this in the past. And the financial forecasting also ensures that public funds are used effectively and efficiently. Note that when we are talking about projecting revenues and expenditures, then of course the financial forecasting can also serve as a basis to estimate deficits or surpluses that you may have. Financial forecasts can also serve as a justification for spending and resource allocation in your budget, and the advantage is that you have the ability to model and simulate changes in funding or financial outcomes based on changes in the macroeconomic environment or based on policy parameters. Now, of course, there are many examples that are related to financial forecasting, and here I have just listed a few, like sales tax revenue and motor fuel tax revenue, as well as expenditures for teachers or expenditures for road maintenance. Of course, you can also have non-financial forecasts. For example, if you're thinking about service demand, where you are interested in the number of school places that you need for children, or the number of garbage bin collections that you have to do per week over the next couple of years. Now, forecasting in the public sector and also in the private sector is fairly similar. However, there are some differences. For public sector funding, the focus is usually on the service provision, whereas for the private industry, it is usually on the maximizing profits. Also note that changes in the environment for public sector or for public institutions can take a while. Think about taxes, grants, or appropriations may actually take longer to change, and they may have a longer impact in the future in terms of revenue and expenditures. Whereas firms in the private sector can adjust more quickly, for example, by changing the price in order to cover revenue shortfalls or meet their budgetary expectations. Now, there are many challenges associated with forecasting, and note that those challenges are similar for public institutions as well as for the private industry and the non-profit sector. First challenge is associated with the data availability and also the quality of the data. Basically, we have mentioned before that if you want to conduct a forecast, then that forecast is based on historical data, and you need to have access, or you need to have collected that historical data in order to do a forecast. And even if you have collected the historical data, there may still be inconsistencies about data collection methods. For example, you have changed your method of how you collect the data, and this can lead to data gaps and missing values. Now, for public institutions, you also have multiple stakeholders that all have different expectations. So you can think about, you have the expectations of political entities, you have the expectation of the public opinion, but of course you also have the expectations about the people you are providing the service to. very much like any institutions, also public institutions or entities have budget constraints that may limit the funding to do actually forecasting. If they don't have a particular, for example, if they don't have a particular expert that can do the forecasting for them. Also, sometimes they have restricted resources for data acquisition and model development. And there is also a certain dependency on public funding cycles. Now, very much like private institutions, public institutions are also governed by external uncertainties. Think about the COVID-19 pandemic, or think about economic volatility more generally. There may also be technological limitations, in the sense that they have a limited access to advanced forecasting software and tools. And there may also be a lag in adopting the modern data analytics technologies. And I haven't mentioned this before. For example, due to budget constraints, there may also be constraints in terms of technical expertise and training. Now, you can imagine that long-term forecasting is very difficult. So forecasting, say, the general tax revenue over the next year may be relatively simple compared to forecasting the tax revenue, for example, at the national level over 10 years. Note that the Congressional Budget Office actually does projections about deficits, revenues, and expenditures over 10 years. So this may be very difficult to actually capture correctly or accurately long-term trends. Public institutions also have regulatory and compliance requirements, for example, of how the money is spent, depending on how the statutes are written. Now, we have seen that public institutions or public entities need to engage or should engage in forecasting. And now the question is, how are they actually engaging in forecasting, and what type of models can they be using? Note that here I am just starting with the basic models, and there are actually many more models that are out there. So think about this as right now as simply an introduction. So the forecasting techniques that we are going to look at is what is called the moving average. Then there's also exponential smoothing, and we are going to touch very shortly on regression analysis. Note that regression analysis, there is going to be a case study associated with that, and this will be covered in a separate video. Now, more complicated is what is called time series analysis, and we are not going to cover this. But this is also one approach of forecasting techniques that can be used. The considerations for which type of model is actually used, or for what type of forecasting technique is used, really depends on three things. It depends on the data availability, so what is the type and the amount of historical data that you have. It depends on the forecast horizon, like the short-term versus the long-term needs. And then it also has to balance complexity versus accuracy, in the sense that you can use, for example, time series analysis or regression analysis that is highly complex, but it may not be as accurate as other, or it may be as accurate as other more simpler forecasting techniques. So let us look at moving average models, and you can think about moving average models as using averages of past observations to smooth data and identify trends. Here we are only going to look at the simple moving average model, where we assign an equal weight for each period. The example that I'm going to use is 2011 to 2020 hunt and fish license tax revenue for the state of Washington and the state of Idaho. In the next slide, we are going to look at the trends, and we are also going to look at the calculations of how to do a moving average and trying to predict 2020 based on a 2-year and a 3-year moving average. Now, the 2-year moving average will be for 2018-2019 to predict 2020, whereas the 3-year moving average will use the data 2017 to 2019 to predict 2020. Now here you can see the tax revenue for the hunt and fish tax, license tax for the 2 states. And what I would like to highlight here is that I have picked those 2 states as well as the hunt and fish tax revenue, because both states are slightly different in the sense that for the state of Washington, you have a rather constant revenue over time, whereas for the state of Idaho, you have an increasing revenue over time. And we will see that there are consequences associated with the flat versus the increasing revenue when you are using a moving average model. Now here, I have mentioned before that we are going to use 2-year and 3-year moving averages. And so here you see the data. So note that we have the 2020 data here, which is the observed value for Idaho. And we have the observed value for Washington. You have also the observed value for the previous years from 2017 to 2019 for both states. Now, if we want to predict 2020, of course, assuming that we are in 2019, for example, then if we are calculating a 2-year moving average for Idaho, that would give us the value of 47.94. How do we calculate that? Well, the moving average is that we are taking 46.43 plus 49.45 in order to predict the average, in order to predict the value of 2020. If we do a 3-year moving average, that would be the average of the last 3 years from 2017 to 2019. Note that we have a difference here in terms of the predicted values from the relative values. That is the 2-year moving average is 15% lower than the observed value, and the 3-year moving average is 18% below the observed value. Now, if we are applying the same technique to Washington, we see that the difference is much smaller. Now, remember that for Idaho, we had an increasing moving average, and that means we had an increasing trend, and that means that in general, the revenue or the next data point is underestimated. So if you have an upward trend, then you are underestimating the next time period. If you have a downward trend, then you are overestimating the next time period. Now, before I have said that we are using a 2-year and a 3-year moving average, but of course this really depends on the length of the available data and what type of forecasting you would like to do. Now here on the next slide, I have actually plotted the data series again, but I have also included the forecasts. And so you can see that you have the 2020 actual value, which for Idaho, which is up here, and you have the 2 forecasted values here. And there's a significant difference between those 2 values. But for Washington, you actually have a relatively accurate forecast because the line remained flat over a long period of time. Now, there are various other techniques, and the next one that we are going to look at is what is called the exponential smoothing method. Now, there are multiple exponential smoothing methods. For example, we have the simple exponential smoothing, we have the Holt's method, and we have the Holt-Winter method. Now, note that we are only going to cover the first 2, where the simple exponential smoothing does not assume any trend or seasonality, and the Holt's method can actually handle trends. Now, Let us look at the simple exponential smoothing. A requirement for this method is that there is no clear trend and no seasonality. And note that the next period's forecast, which I denote y t plus 1, is a weighted average of the previous period's forecast and the observed value. Note that the little hat here means that we are talking about a predicted value and not the actual observed value. So the equation would be that you are choosing a smoothing parameter alpha that is usually between 0 and 1. Usually the values should be about 0.2, 0.3. And so you are taking the observed value in time period t, or for example, the observed value in 2019. And you are multiplying that by the smoothing parameter plus 1 minus alpha times the predicted value for 2019 in order to get the predicted value for 2020. Now let us look at how we are actually implementing the simple exponential smoothing method in Excel, and note that you have the description on the slides. I have already done the core setup here in the sense that I have the observed value in column B. Those are the observed values. And then I also have the forecast where I'm going to calculate the forecasted values. And I have picked the smoothing parameter alpha to be 0.3. Note that this is nominal data about the hunt and fish license tax revenue for the state of Washington. So the initial forecast is simply going to be the first observed data point. So in cell C2, we're simply writing equal to B2. And so we have the forecast for 2001, which is basically how we are initializing the model. Then for the remainder of the forecast, so the forecast for 2002 in this case would be the smoothing parameter times the value from the previous period, the observed value from the previous period, plus 1 minus the smoothing parameter times the forecasted value of the previous period. Okay. So here note that if you are dragging this, down, then we need to have the smoothing parameter remain in cell D1, so we can put dollar signs around this. And then we're now having our forecast all the way up to 2023. And you see that it is always the smoothing parameter times the previous observed value plus 1 minus the the forecasted value from the previous period. So this is how you're going to do the simple exponential smoothing. Now the Holt's method is an extension of the simple exponential smoothing, in the sense that we are adding a trend component here, but again we are not using seasonality. Now there are two equations that you need for the Holt's method. You need one equation for what is called the level, and you need one equation for the trend. And then the forecast would simply be the addition of the two variables, of the two equations. Now for the Holt's method that expands on the simple exponential smoothing by allowing for a trend, the setup is slightly more complicated, and I have already put in all the equations and formulas here. So note that as before, you have in the first column you have the years, And in the second column, you have the observed values that you have from historical data. Now, the level is simply the first observed value, and the first trend is the simply the difference between the observed values of the first two time periods. Now then, for the level equation, what you're doing is you are using the smoothing parameter. That very much like before, you are using the smoothing parameter and multiply it by the observed value plus 1 minus, and then you're again using you're multiplying it by the previous level, like you have done with the exponential smoothing, but you are actually adding that trend into that variable. And so that would give you the level, in this case for 2012. Note again that if you are using Excel and you are dragging the columns down, or you're dragging the cell down to copy the equations or the formulas, you have to make sure that it always stays in F1, which is the reason why you have those dollar signs there. For the trend variable, we are using a slightly different method. There again, you have this smoothing parameter beta, where you're taking the difference between the levels plus 1 minus that smoothing parameter for the trend times the previous forecast of the trend. So you're basically able to update the trend component. There's not a constant upward trend, but you're adding a trend component that is updated with each step. Okay, so that would be the Holt's method for exponential smoothing. The last method that can be used is regression analysis, or the last method that is actually covered in this video is the so-called regression analysis, where we are looking at the relationship between a dependent variable y and one or more independent variables x. Now, if we have a simple linear regression model, then we are predicting, we are doing the predictions using just one independent variable. For multiple regression, we are looking at the predictions using multiple independent variables. Note that regression analysis is usually also the bread and butter for any social scientist. Now, the last part is going to cover scenarios, sensitivity, and risk analysis associated with your forecast. Now, think about the forecast as mathematical models, where you can actually change the inputs, the input parameters, and then you can see of how those changes in the input parameters are changing your forecast. This may be important if you're thinking about linking the general sales tax revenue as a function of income, and you can think about how the income then is going to, how the growth of income may affect the general sales tax revenue. Basically, you can run different scenarios that help you plan for uncertainties by modeling various outcomes. For example, different growth parameters in the for real income then that influences the general sales tax revenue. Usually when you're doing the scenario analysis, you want to calculate a baseline, which is the most likely outcome based on current information, but you also want to include upper and lower bounds, which I have called here best case scenarios and worst case scenarios. Basically what that would do is it would give you an idea of the upper and the lower bound of your forecast depending on assumptions about the environment. You can also do so-called what-if analysis. That is basically you are changing specific variables and look at the impact on financial forecasts. This may actually then give you insights about the sensitivity of those forecasts to changes in key factors. For example, the inflation rate or the unemployment count. This then has multiple benefits in the sense that it improves your planning, that you can plan for various environments that you might find yourself in. You can also enhance the decision making, and given that you are including various scenarios, this may also enhance transparency. Now, the scenario and the sensitivity analysis is also closely related to risk analysis, where you are thinking about the likelihood of or the potential impact of uncertain events on financial forecasts. So you can think about the risk of a very high, say, snowfall amount, and how that would actually impact the Department of Public Works expenditures in terms of salt and snow truck use. So this concludes the video about the basics of financial forecasting in public institutions. Goodbye.